Hello everyone, welcome to our channel Everyday e-Learning. In this playlist, we are going to cover some of the chapters from probability and statistics. And in today's video, we are going to start with topic 1, which is probabilities. So let's get on to the first problem. It is asked what is the sample space when a coin is tossed 3 times. All right, very easy problem. Let's start with what happens when a coin is tossed once. So when a coin is tossed once. So when a coin is tossed once, we have the sample spaces head and tail. Fine. This is pretty basic. Now let's go and find out when a coin is tossed 2 times. What happens then? So we can use the tabular structure here to determine head, tail, and head, tail. So we'll have head, head, tail, head, and head, tail, and finally tail and tail. Therefore, the sample spaces can be head, 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 tail, tail, head, and finally tail and tail. Now let's find out when a coin is tossed 3 times. What happens then? So at first we draw the sample space tabular structure here. So above we'll have head, 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 tail, tail, head, and tail, tail. And in this line we'll have head and tail. So the possible sample points can be head, 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 tail, head, tail, head, and head, tail, tail. And for this one it will be tail, head, head, tail, head, tail, 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 head, and tail, tail, tail. Therefore our sample spaces for 3 times of a coin toss are head, 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 tail, head, tail, head, head, tail, 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 head, head, tail, head, tail, 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 head, and finally 3 times tail. Now let's move on to the second example we have got here. It is asked what is the sample space for the number of aces in a hand of 13 playing cards. So as we all know that our number of aces in a deck of cards can be maximum 4. Fine. And number of given cards here is equals to 13 in our hand. Fine. So what they have asked number of aces in a hand of 13 playing cards. So if we are given 13 playing cards in our hands, then it is evident that we can have no aces. We can have 1, 2, 3, or maximum 4 aces in our hands out of 13 playing cards. Now let us move on to our third example. So in this example we are given that an experiment has 5 outcomes. 1, 2, 3, 4, and 5. If a probability of 1 equals to 0.08, probability of 2 is 0.20, and 3 is 0.33, what are the possible values for the probability of outcome 5? This is the first part, and the second part is 4 and 5 are equally likely. What are their probability values? All right, at first let me divide it into 2 parts, the screen, and then we'll start with the first part. In this we are to find out the probability of 5 equals to what. So we all know that for any experiment the total probability is equals to 1. For any random experiment, total probability equals to always 1. So we can write here that probability of 1 plus probability of 2 plus probability of 3 plus probability of 4 plus probability of 5 will be equal to 1. Now we need to find probability of 5. Alright, so we can write here that taking all these to the right side, we can write minus 0.08 minus 0.20 minus 0.33 and minus probability of 4. So we'll have here probability of 5 is equals to, we'll have 1 minus all this will be 0.39 minus probability of 4. Fine enough. Now we are given the condition that probability of 4 and 5 are equally likely. It is mentioned that they are equally likely. Fine enough. So if they are equally likely, we can understand that the probability given here will be shared between these two. So we can conclude from here that probability of 4 will be equal to probability of 5 and it will be equal to 0.39 divided by 2 as they are equally likely. So 0.39 divided by 2 will be equals to 0.195. It will be the value of the probability of number 4 and 5. That's it. Now the fourth and the last example of today that we have is this one. An experiment has 3 outcomes, alright, 1, 2 and 3. If outcome 1 is twice as likely as outcome 2, alright, this is our condition, and outcome 2 is 3 times as likely as outcome 3, what are the probability values of the 3 outcomes, alright? So in here we are not given any values directly, but we are given the conditions to help us find out the values, alright? So at first, let probability of outcome 1 we have be denoted by probability of 1. Alright, so in this way probability of outcome 2 equal to, alright, okay, what is this thing that is disturbing? Sorry for that. So and probability of outcome 3, we consider probability of 3. Fine enough. So let's now follow the given conditions. According to the conditions that we are given, we can write that probability of 1 is equal to twice the probability of 2, right? As it is given here, 1 is twice as likely as outcome 2, and we can also write that probability of 2 is equal to 3 times probability of 3, as we are given in the second condition. Outcome 2 is 3 times as likely as outcome 3. All right, so we have the two equations here which we can use to determine the probability of the individual ones. So here we can write that probability of 1 is equal to 2 into 3 times probability of 3. So we have 6 into probability of 3 here. Now, okay, let me move on to a bit that side. Okay, now we can write that, as we all know, sum of all the probabilities in an experiment, random experiment to be precise, is equals to 1. So we can write probability of 1 plus probability of 2 plus probability of 3 is equals to 1. Now we can replace probability of 1 with 6 into probability of 3 plus probability of 2 with 3 into probability of 3 plus probability of 3 is equals to 1. Now we have all changed all the values to a particular one, probability of 3, so that it will help us to solve our problem easily. So we can write that 10 into probability of 3 is equals to 1, and thus probability of 3 is equals to 1 over 10. Now it will help us to determine the other values as well. So we can write that probability of 2 will be equals to 3 into 1 over 10 equals to 3 by 10, and probability of 1 is equals to 2 into 3 over 10. Sorry for that. 2 into 3 over 10, and we'll have 5, then we'll have 3 over 5. So these are the three probability values we have for the three values. So thank you very much. That's all for this video. If you have any confusion regarding this topic or any other problem that you need to be solved, that you need solution of, please feel free to comment. Thank you very much.